Welcome to Technexum Systems. My name is Peter Anderson, and I have been designing, building, and supporting production systems since 2003. That's over 20 years now. And over that time, I have seen what works, what fails quietly, and what businesses are forced to rebuild because the foundation was wrong from day one. In this video, we're going to design a virtual server network environment for a small business. This is not going to be a lab setup to pass certifications or a demo built to sell software. What I will be doing is building one physical server, running a hypervisor, controlling several virtual servers. This is the kind of architecture designed to support businesses in daily operations where reliability and consistency matters. We're going to focus on design first because when the design is right, everything else becomes easier. And when it's wrong, no amount of troubleshooting can fix it. Plus, as the saying goes, if you fail to plan, you plan to fail. In this video, we are not installing anything yet. This video is about architecture because if the design is wrong, everything else fails no matter how well it's installed. We're going to walk through the physical layer, the virtualization layer, the network layout, and the role of each system, and more importantly, why each one exists. If you skip this step, you don't save time, you create future rework. First, let's define the scenario we are going to work with. This is a small business, employ about 10 to 20 people. Those are going to be our users, and they're all working out of one location. And there is no full time IT staff. They will need centralized logins, file access, basic security, and something that can grow without being replaced in the future. This reflects how most businesses operate in practice. At the core of this environment, it is going to be the virtualization. What that means, we have one physical server, a hypervisor running on top of it, and multiple virtual machines running within. Virtualization isn't about appearance or trend, it's about isolation, recoverability, and control. When one service fails, the entire business should not fail with it. Now let's look at the parts we're going to use to create our virtualized environment. The first thing we're going to look at is the physical host. This is the actual hardware, the CPU, the memory, the storage, and the network interface. The users that we are going to be creating this for will never interact with this directly. It exists for one purpose only, to provide stable resources to the virtualization that we are going to put on it. No application will be installed here, no services, no shortcuts. Mixing workloads directly on the host is one of the fastest ways to create instability and make troubleshooting impossible. So, this machine is just to manage the virtualization. Next, we will be looking at the hypervisor. So after installing whatever server software you will be using, it's now time to install the hypervisor. This is the control layer that creates and manages the virtual machines. This hypervisor is responsible for CPU scheduling, memory allocation, disk access, and network connectivity for every virtual system in the environment. If the physical host is the foundation, the hypervisor is the framework. When this layer is misconfigured, you don't just get one broken server, you get unpredictable behavior across the entire environment. In this slide, we will look at the virtual network. The virtual network is configured within the hypervisor. This layer governs communication between virtual machines and the physical network. When it's not designed correctly, issues surfaces as authentication delays, DNS failures, or backup interruptions, or you might see an inconsistent network behavior. These are just signs of a misconfigured network layer. Before we talk about the other components, it's important to understand how authentication actually works. And this is not just for virtualization. When a user signs in at a client workstation, that computer does not make any access decision on its own. The login request travels from the client through the virtual switches to the domain controller. The domain controller verifies the user's identity, checks group membership, applies security policies, and then return the result. Only after that process completes does the user gain access to the system. This is why DNS and network configuration are so critical. If a client can't reliably reach the domain controller, logins become slow, inconsistent, or fail entirely. When businesses complain that login takes forever, this is usually the flow that's broken. Here is something else to look at before we continue, and this is file access flow. This follows a similar path but serves a different purpose. After a user is authenticated, access to business data is still controlled centrally. When a user opens a shared file or folder, the request travels from the client through the virtual switch to the file server. The file server checks permission, validates access, and delivers the data. This design ensures that business data lives in one controlled location, not scattered across individual machines. It also means backup, security auditing, and recovery can be handled consistently. When businesses keep this model and store data locally, recovery becomes manual, unreliable, and expensive. At this point, everything we have discussed so far depends on one critical layer, the virtual switch. The virtual switch is the intersection between computers, storage, authentication, and data access. Every login request passes through it. Every file request passes through it. Every policy application depends on it. When this layer is misconfigured, the failures are rarely obvious. Users can sometimes log in, file access might work intermittently, backups may fail silently, And because a problem isn't tied to a single server, it often gets misdiagnosed as hardware issues, DNS problems, or slow computers. In reality, it's a design failure, not a performance issue. This is why we treat the virtual switch as infrastructure, not a default setting. If the switch isn't designed intentionally, everything above it becomes unstable no matter how well the individual servers are configured. Okay, now let's look at the other components in our virtual environment. And the first actual server we're going to design is the domain controller. This system handles all authentication, all DNS, and directory services. In plain terms, it decides who can log in, what they can access, and where systems are located on the network. This machine is not optional in a business environment. Without it, you do not have centralized control. What you have is chaos. The next server we're going to design is the file server. If you're going to do a small business and you're only going to have two machines, then these are the two servers to have: the domain controller and the file server. As I said before, you don't want to use the host for anything else other than controlling the virtualization environment. So, to share files across the devices, you need a file server. So, we're going to have a dedicated server just for file sharing. This is where the business data is going to live, not on desktops, not on shared USB drives, not scattered across random cloud accounts. Centralizing data is what makes backups, permissions, and recovery possible. When this role is skipped, data loss becomes a matter of time, not chance. Okay, the next thing we're going to look at are the client machines. Now, employees should never be signing into the servers to work from. They should always have their own machines to sign in through, to get to the resources on the network, right? And these we call client machines. These are domain joined systems used by the employees. They don't store business critical data locally. They don't make security decisions on their own. They follow policies defined by the domain. That separation is intentional, and it's what allows small businesses to operate like well oiled machines where each device and server has its role to play. Notice what we are not doing. We are not combining everything into one server. We are not skipping DNS planning, and we are not relying on default settings and hoping for the best. And we are not using the host machine to share files or run any other service from. Those shortcuts work right up until they don't. And when they fail, recovery can be expensive. Okay, let's have another look at the design itself. This design works because each layer has a clear responsibility. Hardware provides resources, the hypervisor enforces isolation, the network controls traffic, the server performs defined roles, it scales without redesign, it's recoverable, it's supportable, And most importantly, it reflects how businesses actually operate. Thank you for staying with us to the end. In the next video, we will begin building this environment. We will configure the hypervisor networking, walk through the design decisions behind it, and demonstrate the impact of common misconfigurations. This is how Technexum Systems designs and evaluates production environments for small businesses. If you're planning a new development, reviewing an existing environment, or correcting issues that never seem to fully go away, you will find a link below to work with us. And if you want a clear, practical understanding of how real infrastructure is designed and operated, subscribe and follow the series. Thank you for joining us.